Hello again. Hope you all are having a fantabulous end of year with your loved ones. So I'm actually still waiting for parts to arrive. Yeah, the holidays sure put a halt on just about all sorts of logistics. So I figured, you know what? Why not take this opportunity and prepare? The next set of videos that we're going to be doing are all on microcontrollers. We're gonna, dive into the world of microcontrollers. Having a solid IDE that's an integrated development environment, it is such a crucial part of software development. IDEs are a lot like our homes, and just like homes, IDs come in many flavors. Some homes are pretty basic, that might have all the classic things, but none of the bells and whistles that a modern home might have, right? So when we're looking at IDEs, features like, code auto-completion and syntax highlighting and debugging tools and version control, right? These are a lot like homes that have modern appliances and super efficient heating and cooling systems, right? Or a state-of-the-art security system. And some IDEs even allow you to expand its functionality by means of things like a plugin system. This is like a home that can rebuild itself and expand itself as needed. That's pretty wild. It's like the home of the future, right? Anyway, today's goals are install the tools. We're going to get familiar with the tools, create a very simple project, compile it to make sure the tools all work. We're going to load it into the microcontroller, and that's it. So if you want to tag along today, you're going to need a computer because we're going to be installing some software. PlatformIO is going to be installed as a plugin of VS Code. I'm going to be using the STM32 Blue Pill. There's going to be links down below, but you're going to be using the ST-Link V2 programmer. Well, I'm going to be using this to load the code into the microcontroller. Here is, if you want to get one, right? If you don't have one, if you want to get a microcontroller, two things that you should be aware of. First, ST-Link V2 is what you need. This is the microcontroller. Sorry, this is the programmer for the microcontroller, okay? And the microcontroller we're actually using today is this Blue Pill. This is what the Blue Pill looks like. It looks just like an Arduino Nano, a little bit wider-ish, just because there's a little bit extra space after the pins, but that's about it. These come in different flavors, okay? So make sure you check the model, right? So this C66 this is actually the model I'm going to be using today, and I'm using it only because I ordered these by mistake. So why VS Code? Why PlatformIO? Well, this answer is actually really simple. So far, it's probably the best development environment that I have come across for microcontrollers. PlatformIO, it has a really, really large hardware support. It supports a lot of boards. Also, the community has built support for the Arduino framework. So if you use PlatformIO with the Arduino framework, you can pretty much guarantee that your code is going to work on a lot of microcontrollers without having to change much. VS Code is an open source. Well, actually, I don't know if it's open source, but it is free. It has a lot of support for a lot of languages. The toolchain is super complete. In fact, is just as good as many of the paid IDEs, the commercial IDEs that I've used, in some cases even better. It is by far the best experience you can get at that price point. So we're going to use it. Okay, so installing VS Code and PlatformIO is actually quite simple. So I'm not going to go through the whole installation, but we're going to talk about it. VS Code, there's a link down in the description, but all you have to do is just go to code.visualstudio.com/download, and you're going to pick the platform that you are using, whatever computer flavor you want. I'm on a Mac, so I will choose Mac. Download, right? Download will get started, and once it completes, you're gonna install it just like any other program for your system, right? So when you first install VS Code, you're gonna see this basically here. And to install PlatformIO, what we're going to do is we're going to go to this icon right here, the extensions icon, and we're going to look for PlatformIO. And we are going to pick this top one, which is made by PlatformIO, which has this little sign right here that says, verified or whatever that check mark means. And then you're just going to click install, and then you're going to wait. You may need to reload the thing to work. If you've never had it before, but if it's cached, it might already start working. Okay. What did installing PlatformIO give us? Well, PlatformIO is this additional plugin, which is this area right here, right? So this is the home. And to get to it, when you click on it, you get this menu over here, which has various things. There's this thing here at the bottom that you expand. You have this quick access. And you have the PlatformIO home, you have a debugging section, and then you have some additional miscellaneous stuff. We're going to talk about the PIO home right now. Okay, so what is this? So in the home, this is where you get to see all the projects that you have created. This is where you can create a new project. You can also import an existing project. You can open a project. You can even get some project examples. Okay, if you have created a project, then they will, right here in the project section, this will give you all the projects that PlatformIO is aware of. And then to open it, you can open it directly from here, or you can configure it. So inspect. This is a place where you can do code inspection. And what this will do is, so if you give it a project to browse, right, like an existing project that you have, say like, I don't know, let's pick this random Honeywell 2 operator FM, right? You guys are probably familiar with this one. Maybe not. If not, maybe I'll put a link in the description. You guys can go check him out. He has some really cool stuff. And so if you inspect it, it does take some time. And especially for larger projects. This is a small project, so maybe it's not going to take that long. As you can see, it's already at 25%, and I've just been talking for a few seconds. And then it's going to give you just some useful information about possible issues, libraries that may be old, or see over here, for example, it find a few defects, which may be issues, maybe not. Okay, libraries. So this is where you can search all sorts of additional libraries available for use. These could be things like adding support for an LCD display, some other kind of peripheral that you might want to connect, right? So this is really, really good, right? Because it saves us having to write it ourselves. If you start typing something like, I don't know, Mozy, right? Mozy is a library for DSP to use with Arduino. And so, here's how we would do it. You go and you select it, and then you can install it, right? You can add it to an existing project. It's really that simple, okay? So these are libraries. Boards, okay? This is where you go select the board, type of board that we're using. So today we're using the Blue Pill, right? Blue Pill. I think it's one board, right? So here's Blue Pill, and there's support for quite a few of them, right? So I'm using this one at the top here, so that's the one that I'm going to be selecting when I create my project. Something really interesting about this, right? So if I click onto one of these, this will take me to the website. And let me bring over the browser again, so it's right here. And on this website, I can now go see, you know, what the microcontroller is, some information about the microcontroller itself. This one has 32K, actually it's 32K of flash RAM, 10K of RAM, some generic. So this one is generic, but it's actually ST, and that makes this microcontroller. Down at the bottom here, you also see what frameworks it supports. And this is really important for us, right? Because we want to use the Arduino framework so that we have more access to tools and libraries. Platforms, they're different from frameworks. So think of platform like the code that is needed to run a certain type of processor. So Arduinos are all running Atmel processors, right? So they run on the Atmel AVR platform. The ST microcontrollers run on the STM32 platform. Framework, on the other hand, think of that as an abstraction layer, right? That abstraction layer allows you to interface with the hardware without really knowing too much about the hardware. It tries to generalize it so that we can interact with it in a much easier way. So yeah, so platforms are more like a family of hardware, while frameworks are more like an abstraction layer that lets you interact without having to know anything about the hardware itself. Devices here are referred to the communication ports that are going to be used to talk to your microcontroller. Okay, you typically don't have to really do anything in here. In fact, if you see over here, like the only option is to refresh. So let's go ahead and create a new project. So to create a new project, you just go back to home, either from here or from here. And we're going to say create new project. And then we're going to give our project a name, something sensible like hello world, blue pill. Okay, so we look for a board. And I have this T6, right? So I'm going to choose that one. And I want the Arduino framework. I'm going to choose the default location, which you could change if you want it. And then I'm going to say finish. Okay, so let's see what this did for us. So we have these top two folders. In fact, anything with a dot, it's going to be a hidden file, and it's usually more likely it's going to be some kind of configuration file. So these particular folders here are specific to PlatformIO and VS Code. We're not going to touch anything in there, but just be aware that these were created and they really should be there as part of the project. PlatformIO needs it, so does VS Code. Okay. The include folder is where you put your code. If you are writing code in an object-oriented fashion, which we will do as we progress through the series. The lib folder, this is where libraries can go. If you're adding libraries manually, they will go in here. If you, however, are including libraries using the PlatformIO method, it will be done automatically, so you don't have to worry about that. Just be aware that libraries, when they do get installed, they need to be pretty much contained under a directory structure. That's what this is right here, and it tells you a little bit about it. SRC folder is where your code goes. Unlike Arduino, where you have a sketch name .ino, over here, all our projects are going to contain a main.cpp, and that's the equivalent. And in fact, if we look at it, you'll see that this structure looks very, very similar. One major difference, right? This is this main.cpp, this is where your code goes. We are manually including the Arduino framework, right? This is what this include statement right here is about. And it needs to have this in order for it to work, right? So if you just copy a sketch over from Arduino, then all you have to do is just add this at the top and it should work, okay? The other thing to note in here, this is, C++, right? So if we're going to be using functions or methods and we put them after the place they're called, it won't work unless we declare them first, right? So we're going to be making sure that we always declare our functions before we use them, okay? We'll get to this when we actually write some code. The test folder, this is where unit testing goes. So if you're writing code for a large team, this is going to be crucial, right? So you're going to be doing your unit test, and then when you're writing code, you're going to be your build procedures, you're going to configure them so that your tests are run every time somebody touches something, right? So that you make sure you don't break something. So that's what this is for. And then you have a few or a couple of files. So git ignore. What this is a file for Git. Git is a version control system, which we will make use of. I strongly encourage you guys to use this. What goes in here are file name patterns, and they get evaluated to the names of files and folders that you don't want included on your backups. PlatformIO INI is a file that we do want to get some familiarity on. This is where the configuration for PlatformIO lives. In fact, you see right here that this environment is basically the board that we chose, right? So I chose this blue pill F103C6, right, which is the one that I have. And then I will declare the platform, right? Here's the board. Here's the framework that I'm using. And then if I was to add libraries, this is where I could include them as well. So it's good to get familiar with this. Right now, this is all we need. Okay, so this right here is just a very simple blinky light example, except I'm not going to be making use of the delay function. The delay function is a blocking function, and anything that blocks the CPU from performing any kind of computation is going to be bad, especially when it comes to audio. So instead, what we're going to do is we're going to use a timer to create the delay. Okay, so let's see if we can compile it. So compiling is actually quite simple. So right here at the bottom, at the very bottom, you see there's a few icons. There's a check, and then there is an arrow, and then there's a whole trash can and some other stuff, right? So the ones we care about today are the check. This is the compilation. This is what's going to upload the sketch onto the board. My cat. This is what's gonna, so this is the compilation. This is upload the sketch. And then one more one that we should be aware is this one right here. Okay, let's try this again. All right, so over here we have the check mark. That is for compiling. That's what we're going to be doing right now. Right? So the first time we compile this, it's going to take a little while because it's going to read through the code. It's going to notice that, hey, I'm using this Arduino framework, and then it's going to fetch all the needed files in order to compile this. So we do this. So as you can see, it fetched everything, and now it's compiling. You get your, outcome, and then at the end, you're going to get a little thing that says success, and that's it. Okay, so we've compiled this, and I have this is the ST-Link, right, programmer, and it's connected to the board. This is the blue pill. If you were using an Arduino, you just connect it to the USB. So now to upload the sketch, you just hit this arrow button, and what it'll do is it'll run the compilation task first, and then it's going to try and upload it. You don't really need to define what port or anything like that. It should automatically find it. So let's go ahead and see this thing blink. Okay, so what I'm going to do, for the sake of completeness, I'm going to compile it first. But notice the output here. It's running through the compilation, and so if I click this button here, it's going to first do that thing again. So it compiled it, and then it's going to upload it. And as you can see, there is the blinky light. Now, okay. With that, we have come to the end. All right. So I really was hoping that today was going to be a simple video. But as you can see, we actually did quite a bit, right? We installed VS Code. We got PlatformIO running. Did a quick little browse through the various areas of PlatformIO, including the layout of the project. And then we created a very simple sketch, and we got it onto the microcontroller. This is going to be part of a multi-series, and so what we'll do is on each video we'll cover the different pieces that we need in order to make this usable for our music projects. So yeah, stay tuned. Have a wonderful New Year's, and I will catch you back in 2024.